Perfect. So I'd like to introduce Zach from Growatt. Um, and for those of you that haven't been in last week's meeting webinar, where we kind of did a higher level overview of the products that Growatt offers and who Growatt is. This is kind of a continuation where we're building on last week's webinar and kind of doing a little bit more of a deep dive into the installation of the Growatt inverters. So why don't we get started, Zach?
Sure. I appreciate the introduction, Danny. My name is Zachary Kieran, and I'm here today to present the battery storage and installation training, as well as the inverter installation training. So this is covering the MIN TL-XHUS and the APX battery, the high voltage battery. So today I'm going to familiarize you a little bit to the Growatt ecosystem. We're going to cover some of the installation of the rapid shutdown, the MIN inverter, of course, the APX high voltage battery. And I will show you how each of these systems fit together to complete a reliable and safe PV plus energy storage system. So everything you see kind of in this picture here is what we're going to be going over today. And I'll show you how to interconnect everything as well. So just a quick introduction to who Growatt is for those that maybe missed the last webinar. Growatt provides a wide range of products and solutions, including PV inverters, batteries for energy storage, EV chargers, and smart energy management. Here at Growatt, we are dedicated to the research and development of these products, which will eliminate the customer's reliance on fossil fuels to power their everyday needs. Just going through the industry, we have attained some very prestigious accolades with our experience. We are the #1 residential inverter supplier globally. We are globally the top 4 PV inverter supplier, and we are the global top 4 hybrid inverter supplier. And these are all from Frost McKenzie, a data analysis research company. Together, we are climbing mountains and driving customers really to new heights. Over the past 4 years, we've expanded our organization around the globe and achieved fast growth with a compound annual growth rate at over 92% between 2019 and 2022. In coming years, we expect the storage and solar energy market to absolutely flourish. And with our technological strengths, we'll be able to seize those market opportunities. We have over 1.9 million cloud users, 3.1 million annual inverter production capacity, over 180 countries with our products installed, and we continue to invest in the development of the products that we offer. So around the globe, we have solutions for pretty much every energy desire. Growatt is dedicated to finding the best solutions for our customers' needs, including residential, EV charging, commercial solutions, off-grid solutions, whole home and critical load backup, and even the portable energy market. The Growatt portable power station is really interesting. I was skeptical about portable power stations at first, but I use my portable power station for pretty much everything now, including family functions, camping. There's many different ways that I've used it. So just take a look on our website. You'll see some of the products that we offer. But with Franken Solar, we are celebrating an exclusive partnership for the residential inverters and the battery systems, as well as our whole home energy backup solution as well. So we're dedicated to this partnership as it brings two like-minded companies together to create a truly renewable future. So we're celebrating our exclusive partnership in the Canadian market, and our solution is readily stocked and available only from Franken Solar Americas. So what sets the Growatt installation apart? From other products that are in the market, we are going to see in this webinar exactly how you can install and commission the APX battery and the MIN inverter in under 1 hour, which is exceptional for a full energy storage solution. We are going to save you and your team time and resources while implementing a reliable and sustainable home energy system. So we're going to start off a little bit with the MINTL XHUS inverter, and then we're going to progress through the webinar as such. So we're starting off here, some of the installation procedures, and we'll highlight the ease of the implementation. So to give a little bit of background about the MIN, it is our flagship battery-ready residential inverter. The MIN is a hybrid inverter with a sleek and streamlined design. The product comes in a wide variety of power class options ranging from 3 kilowatts to 11.4 kilowatts. The product has built-in production and amortization monitoring, is very easy to install, and features a 10-year warranty which can be extended to 20 years to follow the life of the array. The product can be installed and commissioned in as little as 15 minutes to save the customers installation resources during many different product installations. The MIN features a whole home backup solution with the SYN product, supports some critical load backup as well with some other sub panels, and supports module level shutdown with either a TIGO or an AP smart transmitter built inside. So installation best practices for the MIN inverter are as follows. It is only permitted that the inverter be installed on a wall with no greater than a 15-degree tilt. This is important for reducing possible issues with the system as time goes on, and it is not permitted that the inverter be installed flat, with a forward pitch, or, of course, upside down. You know, we have to put this in here because at least someone somewhere would definitely try to mount the inverter. So the inverter should be clear of any obstruction in all dimensions with a 1-foot separation from any object. This is to ensure proper clearances for cooling and ensures that there's no requirements for clearance spaces with the inverter. I should note that the inverter is 1 foot on every dimension for the cooling spaces. However, based on the local jurisdiction, there might be some requirements for any objects that are grounded in front of the inverter for clearance requirements. So be sure to check the local electrical code to ensure that you're installing the inverter not in front of a grounded object and against compliance with that code. So some adequate protection of the elements is definitely necessary for the system as well. We don't permit the inverter be installed in direct sunlight. We also recommend the inverter be placed in a way to mitigate the water intrusion to the inverter, such as if the inverter was placed directly in front of the home on the south side. This is not good because the sun would be hitting on it constantly, and it receives some extra wind, snowfall, and rain. So we want to be sure the inverter is adequately protected from these elements. I will say it has a NEMA 4X rating, so there really is no worry about installing the inverter outdoors, but we still want to give the inverter the best possible area to install. So it's important to know also what is included in the inverter box. Of course, you should expect to receive the MIN inverter, but there are multiple accessories and fittings to assist with your installation process. The most important package you will receive is in the installation and operation manual. Please read through that manual thoroughly before attempting any of your installation. But what's included inside the box is the inverter mounting bracket, various screws, expansion fittings, and mounting accessories, some terminal ends to be crimped on the conductors, and an antenna for wireless communications as well. So be sure they have everything in the box, and then you can begin to interface with the inverter a little bit. So here is a little bit of a way to familiarize yourself with all the way around the inverter. On the left-hand picture, you'll see the main panel with the LED indicators and the wiring box cover. We're going to just, this is the most important part, so we'll discuss a little bit more about that as we go through the webinar. On the back of the inverter, it has a mounting bracket and a heatsink it's important to make sure that the adequate spacing was made for the inverter, as the inverter is convectionally cooled. It is not forced air cooled. On the right-hand side, you'll see the DC disconnect switch, and then the different conduit access points for the PV inputs, the battery communication and DC run inputs, external antennas, communication ports, and of course, the grid connection. So here is an example of an inverter installation at our North American warehouse in Ontario, California. So I'm sorry for the funny looking installation. We conduct many tests and various components, configurations to help with the product management. Here we can see the components of the MIN system. The rapid shutdown transmitter is built into the inverter. The rapid shutdown initiation switch input is a simple connection wired from the top of the 3-pin connector that you see here. So this would be for a rapid shutdown switch, but you could also use the DC disconnect as a form of rapid shutdown as well. That'll be the initiator. Conversely, the switch is a little bit more necessary for indoor installations, and if it's not readily accessible to the fire department, it's important to have the safety switch. Next, you'll see the Ethernet input. This is for LAN communication, so hardwired directly from the router to the inverter. The PV plus and the PV minus MPPT inputs. There's the possibility for 2 strings on each maximum power point tracker. We'll discuss a little bit more about the limitations of this in the next few accompanying slides, but these are where the PV array inputs to the inverter. Here is where the battery input is to the inverter. So this is the positive and the negative terminals for the battery. The grounding bus bar is shown here. These are where all of your grounding connections are made. Anything to bond the inverter and the array together is all done with the grounding bus bar. You'll see the grid input here, the L1, the neutral, and the L2 input. And then the battery communication port as well. So this is where the battery communication is entering to the inverter. It's a separate LAN port. So it's shaped very similarly. So the RJ45 socket. So that's the Ethernet port and the battery communication port. So please don't mix those up. The Ethernet port is only for internet access. And then lastly, there's the RS485 Modbus communication. This is for connecting the smart meter to the system. And this is pretty much primarily what this portion is used for. There's more terminals on the right of this, but you should not be using those for certain aspects. The RS485 Modbus port in this picture is shown specifically for the smart meter. Excellent. So once you get the inverter kind of put onto the wall, you'll see the OLED has 4 lights to communicate to the user the status of various system workings. So here we can see the leaf means that power is on. The inverter is not in operating or any of that nature, but it is at least powered on. The power light here will show the power is communicating with the inverter. The wireless communication is shown as well. And then the battery, when the battery is communicating with the inverter as well, you'll see green here. If there are any faults in the system, the fault light will turn red. And this would be the most important LED to look at, in my opinion. So we want to, in normal operation, you'll see at least 2 of these be green. If you have a battery system, the battery will be green. And then no red should be on the fault LED. Excellent. So what are some items that you need to install the inverter for the first time? What are some items that you're going to need? Well, the very first part is you'll need a hex wrench, flathead screwdriver, a multimeter, a hole saw, and a drill, and of course, a crimping tool as well. So before you mount the inverter, it's important to inspect the inverter, the APX battery, and any parts within the packaging for damage. There is no real issue with shipping damage that we have seen or anything of that nature, but anything can happen in shipping. So the most important part is to inspect the products that you have in front of you right out of the box. First, for the MIN inverter, you will attach the mounting plate to the structure. And this is done utilizing our drill. You're going to attach the mounting bracket here to the wall using the screws that are included. And then you can slide the inverter right down onto the mounting plate. It's as simple as only 5 screws to install this inverter. The 3 for the mounting bracket, then the inverter is slid down onto the mounting bracket, and then the bottom end of the inverter has 2 self-tapping areas for screws. We'll include those screws with the inverter, and you'll be able to install the bottom half to the wall as well. So it's really that simple. Before you mount the inverter to the wall, I do recommend, if you have an idea of where the conduit holes for the inverter are going to be, go ahead and drill out those conduit holes first and foremost. It's easier to do this on a table or with the inverter still outside of the box and not installed. When you are drilling out the conduit area with the hole saw, it's important to note not to damage the inverter's internals. It's pretty easy to go a little bit too gung-ho with the drill saw and go through the inverter mounting the outside housing of the inverter and penetrate into the inverter too much. We want to take caution not to do this. Just use your hole saw normally, and you'll be able to screw out a port that is either a 3/4 inch conduit hole or a 1-inch conduit hole. Again, I would recommend doing this while the inverter is not installed. But once everything is installed, you'll need a 5mm hex wrench to loosen the 4 screws shown here. And this will give you access to the inside of the inverter to the wiring cabinet, which I showed in the last couple slides. Great. This is my personal recommendation to all the installers that will install the inverters. I know multiple inverter manufacturers on a way to prevent water ingress and air circulating within conduits, they will seal the conduit ends for their inverter. They'll seal the conduit ends wherever they're terminated. I would recommend doing this. It is not within our manual that says not to do this. But from some of my experience out in the field, from a little bit of my experience just in the industry, I do recommend utilizing a type of sealant to plug those conduit holes. I would also recommend utilizing rain-tight conduit compression fittings. These are fittings that have the ability to seal the end of the conduit compression. I recommend this as well. It's important to mitigate the amount of water ingress that may be happening if these were not used. Great. Okay. So for the PV and battery input connection, we're going to follow the steps 1 through 4 or 1 through 6 here in this particular slide. So the battery and PV input terminals are shown here. We want to ensure that the PV switch is in the off position before we plug the PV array to the inverter. And then before we actually install these, we'll strip about 15mm of insulation from the conductor. And if possible, we can crimp the included terminal ends to those conductors as well. I've seen installations where they do not use the terminal ends. This has come in not a problem in the past. I recommend utilizing what comes with the inverter though. Connect the wires then from PV plus and PV minus 1, 2, 3, and 4. This would be a 11.4 kilowatt system, so it comes with 4 maximum power point trackers. There will be a reduction based on the type of system you have, based on the power class, but this particular is a 4 maximum power point tracker installation. So the limitations for this, the max PV array voltage is 600 volts. This is very important. This aligns well with the residential codes that are in place right now, but it is physically impossible to, it is not recommended to anything higher than 600 volts that could damage the system. Also, currently the maximum power point tracking short circuit current is 16.9 amps. So this will be raised in the future, but for the time being, according to our data sheet, it is 16.9 amps for short circuit current for each maximum power point tracker. The max recommended PV power is 2 times the AC rated power. For a 10 kilowatt system, you could install 20 kilowatts worth of array. And this is really fantastic. The DC to AC ratio being 2.0 gives more accessibility to different system installations. Another note, the PV and battery input cable conductors, that cross-sectional area must be between 8 and 10 gauge wire. And those terminals are rated for 90 degrees. For when you're doing your calculations for derating, those terminals are rated at 90 degrees. Good. And then onto the AC side. So the AC grid connection terminal ensures that the AC wires are not energized first. So it's important that we want to make sure the grid disconnect is not on and those wires are not energized. Again, we'll strip an 18 millimeters of insulation from the conductor and then crimp on those included terminal ends. It's a recommendation. Connect the wires from the grid to the L1 and L2 terminals of the grid port, as shown here. And the breaker sizing depends on what type of power range inverter you have. So for the 3.8, the manual recommends a 20 amp breaker, and then all the way up to a 63 amp breaker for the 8.2 and the 11.4 kilowatt inverters.
This will probably also be a quick reminder for people that there are basically 3 different units that Growatt makes. So there is the 3.8 and 5 kilowatt, which have 2 MPPTs, then the 6 kilowatt to 7.6 kilowatt that have 3 MPPTs, and then the larger ones from there, 8.2 to 11.4, will have 4 MPPTs. So also, depending on your roof, you have to make sure you select the right inverter. So it's not just strictly about oversizing anymore. The price difference between all of these, it's not huge, but just keep it in mind that, for example, the 5 kilowatt only has 2 MPPTs. And if you have 3 roof sections that you want to utilize on a roof, to select the 6 kilowatt or 7.6 kilowatt inverter in that scenario.
Yeah, that's a really great point, Danny. It's really important to fit the inverter to the structure that you're mounting to. Yes. Excellent. So the AC grid conductor cables, 6 gauge to 8 gauge, relatively common, and the terminals again are rated to 90 degrees. This is a little slide that just kind of depicts exactly how the terminals are, how the conductors are input to the terminals. So we really made this an easy process. We didn't want to overcomplicate it with torquing requirements and things of that nature. So instead, we went with a simple clamp connector. The way to input the conductor to each of those terminals is utilizing your flathead screwdriver and then just releasing that clamp down and then plugging each conductor to the recommended terminal. And this is exceptional. This is extremely easy to install. It's no longer the case where we have to worry about, again, about those torque requirements. We have to worry about installing and making sure that everything is crimped in the proper manner and enough wire has been stripped off. Instead, we made it really easy for you. Just go ahead, insert a screwdriver, and then just input the conductor as such. The only conductors that are needed to be screwed will be the AC, all of the grounding bus bar. So any bonding and grounding, these are screw-on connections there. Good. So for rapid shutdown requirements, the inverters include either an AP Smart or a Tigo transmitter built inside the unit. The rapid shutdown initiator button should also be included with the MIN inverter, but this is going to be something that will be an after parts in the future. We're not sure if it should be included yet. The rapid shutdown transmitter button is just a simple mushroom button. Again, that is input, and then the next slide will show you. But the rapid shutdown transmitter sets that heartbeat signal for the PLC devices up on the roof. So each of the rapid shutdown devices will be sensing that heartbeat signal. And then either when the rapid shutdown initiator button is pressed or when the DC disconnect of the inverter is turned off, that signal will no longer be present on the roof, and each of those rapid shutdown devices will turn off. Okay, so they'll no longer be sending their full voltage down to the inverter. So the inverter is compatible with either the Tigo TS4AF and the TS4AF2. So this is the single and the dual module. And of course, also compatible with the AP Smart RSDS and the RSD. So again, the single and the duo. For the wiring of the rapid shutdown system, again, this transmitter is what is built inside the inverter. This will be either the AP Smart or the Tigo transmitter. And then this will be an example of the emergency power off button or the rapid shutdown initiator. So this will be wired directly to that 3-pin conductor we talked at the top here. So what's important to note, there is no polarity to this. It's just a button which is asking for a signal. And then when the button is pressed, it completes that circuit and the inverter knows to instinctively turn off. So 2 different ways for rapid shutdown, either the DC disconnect or the rapid shutdown initiator button. Next is the antenna connection. So the bottom of the inverter features 2 antenna connections. One will be for Wi-Fi communications and one will be for 4G telecommunications. Depending on the model of inverter you have, it may be a 4G or it'll be either Wi-Fi / 4G or Wi-Fi / LAN. So there's 2 different models for the inverter as far as communication goes. If you wish to have the 4G functionality, please purchase that inverter. It acts as a fail-safe in the case that the customer changes their internet password or their internet goes out.
Just FYI, we don't carry the 4G version in Canada. It's more of a US product, I believe. So all the ones in Canada are Wi-Fi only modules.
Understood. Got you. So yes, the Wi-Fi communication antenna will then need to be input to the antenna 1 ports, and that'll be for the Wi-Fi communications.
Yeah. I think it has to do also with just different telecom companies and things like that being involved. So that's maybe why, maybe Alex can speak to it, why we don't offer it.
Yes, yes.
Sounds like Alex is muted.
Got you. So what's important to note then would be the Wi-Fi communication antenna. That's the one that's important. The 4G will not be included in the market for the Canadian market. Okay, so then on to the Growatt smart meter. These are just a few slides about the smart meter installation. This is a easily mounted 35 millimeter DIN rail ready smart meter, which comes with 2 split core 200 amp CTs. This is mainly made to measure the home consumption data, and it's also required for 0 export limitations to the grid. So this is important for certain municipalities that may not allow any feed into the grid. You're still able to use the MIN inverter. You'll just need either a smart meter, and what's the benefit of that is you'll also have your home consumption data. Another thing to note, the smart meter is Modbus communication with the inverter. So you'll need to run either a Cat5, Cat5e cable between the inverter's connection and the smart meter. And we'll show you a little bit more about how this goes. But the SYN device has the smart meter built in. So if you were to procure the SYN device at a later time, you'll no longer either need the smart meter, or if you have the SYN device, you wouldn't need the smart meter anyway. So this is strictly for those inverters that are on grid only. There's no backup functionality. You can install this smart meter into the load center of your home with the CTs. Make sure that the CTs would be pointing in the proper direction where the arrow points to the load side. And the CTs will be installed at the feeder wires on the customer load center. So directly on these feeder wires up top, and the actual device will be mounted on a DIN rail. So the most important things to note about the smart meter is if you do mix up the polarity of the CT, or the CT is facing in the wrong direction, you will not be receiving proper data readings. So it's very important to make sure that the load is pointed, or the arrow is pointed directly at the load center. So the arrow would be pointing down in this case. The L1, L2, and neutral. So here is an example of how it is wired into the system. The L1, L2, and neutral need to be plugged into the smart meter. And this can be done with either 18 or 22 gauge wire. But you'll also need to make sure that there is a small circuit breaker. 10 amps is at the very least. So 10 amps into a circuit breaker into the grid connection. And then the CTs are communicating with the smart meter, and those are pre-wired, so there's no need to worry about wiring the CTs like this. Great. So the smart meter installation will be here. This is where the smart meter Modbus, the A plus, the B minus, so this is the TX and RX receive and transmit. This is where they will be input to the inverter. We're just going to make sure that we have the proper connector pins connected in the proper fashion. So A plus would be on 1, ground would be on the middle, so 2, and then B minus is the very end, 3. Perfect. The smart meter is really interesting. It's very easy to install. It doesn't require very much extra work. Just mounting the DIN rail is the hardest part about it. Okay, so next we'll move on to the installation practices of the APX high voltage battery. So we're going to talk a little bit. I'll detail some of the features of this battery. So this is a modular battery that is ready to be released into the Canadian market. It features a modular design to stack the battery capacity up to 30 kilowatt hours and the maximum discharge power up to 10 kilowatt with the MIN TL XHUS inverter. It supports an automatic balancing function for mixing different packs of state of charge, state of health, and even different years of use. It has a very impressive 90% depth of discharge and an excellent safety and performance rating of the cobalt-free lithium ion phosphate battery. It's another important thing to mention. It is UL 9540A certified. Therefore, it's permitted based on your local authority to be installed either outdoors or again, it just recommended to check with your local authority first to be installed inside in an attached garage or something of that manner. So it is UL 9540A certified.
Sorry to just jump in. Saul had a question about the ATX battery and if that is not recommended, as he saw that we don't carry it. So the ATX is more of an off-grid battery, as I understand it, right? Versus this is more of a whole backup. As to Franken Solar carrying it, the ATX, we will carry the ATX and all the off-grid products as well. We're just implementing this product first and walk through together with Growatt through the entire process and make sure everything is done properly. And then in the second process, we'll bring on the other products.
Oh, that's very nice to hear. It's good to hear that we'll be having a larger portfolio for the Canadian market.
Absolutely.
So
we
yes,
just didn't want to water things down and have too many things to cover at the same time, because we wanted to, this is the product that we see will have the biggest impact right away. And the other products definitely will come as well. Alex and I have talked extensively about this. We just don't want to distract from our focus right now, which is this product. So as soon as all of this stuff is implemented, the other products will follow.
Excellent. And yes, you are definitely correct about the AXE or the ATX battery, mainly for off-grid solutions. It's developed for that. So good to see that it'll be coming possibly. We'll be looking out for it in the near future. That's really nice to hear.
Yeah.
Yes. So, but the most important feature of this particular battery pack, this is the APX battery. This is the most important feature of it is the modular energy optimization functions. So again, this is allowing a longer life cycle and upgradability of the battery pack. So the APX can support automatic balancing of the battery packs for use with different states of charge, different states of health, and different years of use. This feature allows your customers to increase their battery capacity after years of use and will keep the maximum capacity of the battery optimal in various circumstances. The battery uses a lithium ion phosphate chemistry, and again, that 90% depth of discharge is really nice on the market. So a little bit more about that stackable and modular design. It allows for you to select the appropriate configuration for your customer's storage needs. The APX battery is available from ranges of 5 kilowatt hour to 30 kilowatt hour, and it's perfect for small to large residences. Growatt really understood the market demands, and a scalable battery interface was absolutely necessary. So we implemented a solution which could be scaled even after the battery system has been commissioned. And that was the most important part. The battery is not only scalable in the modular sense, but it is future proof for future expandability. This is talking a little bit more about exactly how the automatic balancing function is working. So here we can see different packs of states of charge, different packs of states of use. We don't have to worry about brands of different cells because there'll be only one cell manufacturer. But the most important part is mixing different states of charge and years of use in the same energy storage system. This has made it convenient for supply chain management. It's made it convenient for sales, installation, and of course, maintenance. So let's talk a little bit about the interface of this battery. I'll take you around the product and kind of show you around a little bit. So here is the main interface of the power module. This is the portion that is sitting on top. So each of these battery packs are 5 kilowatt hours, and then the battery module is sitting on top. Okay, and this is what is connecting to the inverter. So this is the interface of such. It features a positive and negative terminal to input to the MIN inverter, as well as an inverter port. So the inverter RJ45 socket is here, and it is the inverter port to communicate with the inverter. Next is the BMU port. So this is communicating between each individual battery module. So this is the battery management unit. This is exactly where each of those battery modules are communicating to. And then the battery module positive and negative terminals. These are again for interfacing with the battery module.
Hey, Zach.
Yes.
There was a question in the chat, and I just want to make sure everyone, even the people that watch it afterwards on YouTube, can get this as they can't see the chat. Can you go over what the max configurations are with the APX battery?
Yes, I can. The maximum configurations with the APX battery are from 5 kilowatt hours to 30 kilowatt hours. That is the maximum configuration.
Per
The
inverter,
battery,
yeah. Per
the
inverter, then you
battery,
can do multiple inverters, right?
it can connect to multiple inverters.
Yeah, no, sorry, you
Yes,
can do multiple inverters per SYN 200, right?
yes, you can.
So
Each
what's
one
the
of those, each one of those inverters could have their own battery system as well.
yes?
Mhm.
So the max would technically be per 1 SYN 200, 90 kilowatt hours of battery, as I understand it. Kilowatt hours of
Yes.
battery, is that correct?
Yes, you have it correctly. So the SYN device has the option for 3 inverter access. Each one of those inverters could have a 30 kilowatt hour battery installed with it to bring the total system to 90 kilowatt hours.
Yeah, and then on top of that, you can install a generator as well, right?
Yes, and then on top of that, the generator installation will
Yeah,
follow as well.
perfect.
We're going to talk a little bit about the SYN device in the next webinar, and I'll be sure to detail each one of those points individually. But for just to scratch the surface with the SYN, exactly right. 3 inverter access, up to 90 kilowatt hours there.
Amazing. Thank you.
Yes, no problem. That's a good question. Yes, so moving on to the battery module interface. So we have the link in ports and the link out ports for the battery communication. So the way that everything is designed is daisy chain technology. So the in ports for the battery positive terminal from the battery above will be input here, and then the next battery in stack will be able to be input here at the output. So the battery can be installed floor to ceiling, uh, or you can separate the battery clusters into sections of 3, sections of 4 and 2, anything to within 30 kilowatt hours. So we're giving you a little bit more expandability here as well. We'll detail that in the next couple slides. As for what is included with the power module, you will of course get the power module and its accessories, the power and communication cables to run between each battery, the mounting accessories for each of the battery modules, and the warranty card. Again, the installation manual will be with it. I recommend giving that a read before you attempt the installation. So what is included with the battery module? You'll notice that the power module and the battery module come with these trim covers. This is to make the battery look really nice after the installation is complete. The APX 5 kilowatt hour battery will be included, and power communication cables between each battery pack. The APX has some very similar requirements as far as spacing goes. So each of the battery pack spacings would be as follows. So it needs 1 foot in each dimension, unless it's going between 2 APX batteries, which are installed together. And then a 2-foot separation is the recommendation from our manual. So each of those battery packs can be installed within 2 feet of each other, or outside of 2 feet of each other, I should say. So there's the mandatory spacing requirements. It can be installed indoor or outdoor, thanks to that NEMA 4X rating. And it must be ready to be mounted on a level surface. So it comes with a floor stand, but which is adjustable, but we still want to make sure that this is on a solid level surface and placed against the wall. A 20 kilowatt hour system is less than 5 feet tall, so it's really energy dense, but the weight is quite heavy. So it's 475 pounds with the power optimizer on the top. So each of the battery modules weigh about 110 pounds, and the power module weighs 35 pounds. It could be a 2-man lift. I do know some that will definitely be able to lift this by themselves. But for installing this battery, just know your own limitations to make sure that you don't overextenuate yourself while lifting up the heavy battery modules. So here's a little bit about the floor mounting plate. Again, it is adjustable. So if the floor is not quite even, you can make sure that you have the adjustments needed to make a floor stand that is very, very reasonable and level with the surface. We'll place the mounting plate with the rounded edges facing forward. I know this picture doesn't do a great job, and if you don't have the product in front of you, it doesn't do a great job, but there's a square end and there's the round ends. And this is how I know exactly what end is supposed to be facing the front. So we want to make sure that the battery modules are installed in the proper orientation as such. Once you have the floor plate ready to go, then you will install the first battery pack to the base. So it's just as simple as lifting the battery on, putting it down onto the base, and then screwing it so that it is secure. And you'll screw it with the included screws, and then the added tab here to secure it to the floor base. And again, I do want to mention the battery can be a little heavy. It's a 2-man lift in certain applications. Next, we'll be wiring the APX battery. So this is the part that I really like. I really enjoy the way that we have optimized exactly how the daisy chain of the DC runs is going. So we'll connect the power module, the plus and minus, to each other essentially. So the link port is connected here. The positive port is orange, and the negative is black. And we will connect each of those in a daisy chain configuration until we reach the very top battery module. And it is as simple as that as far as wiring goes for the entirety of the APX ESS system. It's really easy to do. Each one of these ports are NEMA 4X rated. Again, they're watertight and waterproof, so this can be installed outdoors with no worries for corrosion or any kind of problems in that sense.
So we have a test system in our warehouse in Brampton. So if anyone is in the Greater Toronto area, please jump in, come over for a coffee. We'd love to show it to you. Alternatively, if you're heading to RE Plus, I'm sure Growatt will have a system there, so you can see what these units look like. And then, latest at Electricity Transformation Calgary and Electricity Transformation Canada in Calgary later this year. We will have a full setup there as well that people can look and touch and ask questions at as well. So lots of options there. If you want just pictures, send us an email. We'll send you some pictures of our test system. Please keep in mind it is a test system. It's put up at a wooden board. We're doing testing on it to make sure that everything works the way we like, and this far it has. So yeah, we're very, very excited about this product. That if you want to come have a look firsthand, come in for a visit.
Yes, excellent. Yes, so each of those battery modules are easily connected here, and there's just a locking mechanism to screw each of those locking mechanisms to each battery module, and then the top module as well. So this is how everything is nice and secure. Everything stays together. There's no worry about anything tipping over or anything coming loose in that sense. Everything is locked together. You can use a 3/4 inch conduit for the battery outputs and either a 1/2 inch conduit for the BMS output if you choose. I know that in most circumstances, they will not be able to run together. There is some circumstances within the code where they are. So please check out the code and see when exactly you will be able to route them together. But essentially the inverter and the battery plus and minus have their own conduit access here. Excellent. And that's 3/4 and 1/2 inch respectively. So once everything is done on the right-hand side of the unit, we can move to the left-hand side of the battery pack, and we will need to install each of the bonding jumpers between each of the modules, and then install the final trim plates when you're done. The final battery grounding point will be located right here on the left-hand side of the unit. This is the left-hand side. This is not where it is going to the inverter. We'll see a different portion of this in a second. So multiple battery clusters can be supported together. Again, this inverter can be floor to ceiling, or we can install two different battery modules, basically kind of separated with each other with one main power module. So you'll need to procure some extra extension cables as well as an extra floor base. And currently, right now, the battery positive and minus are working as normal. And then it would go out the bottom through these conduit holes and into the next bottom on the side. Again, as I say, currently right now, they are set up to go to the top. So LinkedIn and PV plus or DC plus and DC minus are going to the top end of the battery. This will be changed in future renditions where it will be accessible from the bottom. So this is how we install two separate battery clusters. The future plans will be the battery, everything is routed to the bottom, and then everything is daisy chained again from here. And the LinkedIn, of course, will still need to be on the top. This is just a part of the daisy chain functionality, but the extra cables and everything that come with it will be included there. So you'll be able to procure those extra extension cables. This is only in the case where you'll need to have two battery clusters. Okay, so lastly, that was with the APX covered. We'll talk about commissioning the system, finally getting the system ready for our customers' use. So we'll need to install the Shine Tools application. This is our commissioning app, and it is the local commissioning app to set inverter settings, such as the grid code, things of that nature, advanced inverter settings with an OSS account, real-time data and operating parameters, internet connectivity, and multiple energy management modes. So this application is available through iOS and the Google Play Store, and it doesn't require an inverter to tour the very basic functionality, but you'll need to have an inverter to really get a grasp of everything the app can do with the inverter. So you can download the app today to see the recent updates. It's been recently updated. So here is a little snippet of what you will see when you first get into the application. You'll see the O&M user and the end account. So most of our installers, most of Franken Solar's installers will have a O&M account. They will need to set that up, I believe, with Franken Solar, and they will be able to then have that OSS account to log into and get to this screen here. Here we'll be able to set up quick site access. We will be able to create our plants, our accounts. The end users accounts are here. You'll be able to add your plants. So these will be all of the plant information. And then the data logger is the inverter serial number. So you'll be able to add that data logger as well here. And what is important about if you're an O&M user is you are in real time creating the end users portals to access their inverter. That's done in this first part. You are creating the plants, which they will then be able to view their inverter, their production data, their consumption data here. And then you'll be able to add that inverter to the plant in this section. So really important, this is how we're creating a plant and logging in for the first time, commissioning the inverter for the first time. This gets everything ready for monitoring. Conversely, if this was for an end user, if the end user needed to access their inverter for whatever reason, you as the installer could give them a code, and that would be the way to enter their password as the end user. So this particular code is 2023 and then the date. So the date today is 8/17, it'd be 08/17. And they'd be able to access the inverter at a basic functionality. But whoever's logged in, it doesn't matter. They can set up the direct Wi-Fi access here. They will go to set, they will go grab their inverter serial number. It'll be displayed here. Click next, and they will be connected to the inverter that they are using. So the very first step when logging into the inverter screen then will be quick settings, network type, and then they'll be able to select what network configuration they need. That'll be either LAN or Wi-Fi. Important to note, and this should be on every screen, no matter where you get the inverter from, the server address should always say server-us.growatt.com. I've never seen it not say that, but it is very important that it does say that for proper Wi-Fi communications, for proper communications with our server. Next, once the network has been configured and the inverter is connected to the internet, we will go through the quick settings, select a grid code for the inverter. And this will be based on the municipality you're a part of. If there's any grid codes that you may need exactly for the system, they can be set here. I recommend just using IEEE 1547-2040. For most scenarios, this is the inverter setting that we utilize. Great. So once the grid code has been entered, you'll be able to select your battery type. If there is a battery with the system, we will need to select the battery type here. You'll have three options. The only option, if you're purchasing from Franken Solar, will be the APX battery option. So battery type, you'll see three battery options, and APX will be the one that you need. Then,
what are the other options, Zach?
Yes, so the other options are the LG Prime and the ARO battery. That is our Growatt, another battery that we have created in the past that we still use in the US market.
Okay.
Yeah, interesting question for sure.
Yeah, I mean, the LG is, I don't see any LG in Canada, and the pricing is obviously prohibitive as well. How is the other one, is it just an older model or?
Yeah, so the ARO,
yeah,
the ARO is an older model, but it's not discontinued or anything like that. It's still a perfectly viable option. It is not a modular level battery. It is a battery cabinet. So that is the main difference. It is a fixed in size. So you can have 6.6 kilowatt hour or a 9.9 kilowatt hour battery. That's just the ARO. It's a completely different system though.
Okay, I'll have to bug Alex about it. I'm curious. Thank you.
I'm sure he'll appreciate that. Yep. Sure. So You select your battery type, APX battery, and then the battery diagnostics. You will need to enter the number of batteries you have. This is my personal recommendation. I want to be sure that the battery is installed successfully and there's no issues. And I'm glad that we've included a diagnostic portion. So if there's one APX battery in the system, you'll just enter the number 1, and the battery is installed successfully is what you will see. This
It
is
looks
my
like
personal
Alex just commented on the topic we discussed. So the reason the APX battery is what's being used here is because it is the one that is system certified UL 9540,
Yes.
and that's why.
Yes, the ARO battery is not UL 9540 certified, 9540A certified.
Yeah.
So that is the main difference between those two batteries. Other than the fact that one's a cabinet system and one's a modular level system. Great. So if you have an SYN device or you have a smart meter, once the Wi-Fi and the battery type has been configured, the grid code has been set, the voltage level should never change unless you are implementing to a 208 volt grid, in which case you will need 3 of our inverters to do this. This is a particular application that can happen. You can have 3 MIN inverters set up on each phase of a 208 grid. So that is a possibility. But 240 will be mostly your option there. And then in the case that we have an electric meter or an SYN device, we will need to select the electric meter in the power sensor area here. So we'll click power sensor, and then electric meter will show up. And that's the one we want. And that allows a proper communication between those two systems. And then the last 2 points I want to mention are the EMS settings and the updating software of the inverter. So the energy management system is utilized to set the priority modes, whether we want to have a battery first system, a grid first option. So these are all different ways to configure the inverter to output either the most amount of energy, be the most self-consuming, or utilize charging from the grid. There's various ways to set up the EMS mode. I would like to just kind of briefly discuss the different options today. We can set those battery settings here. Outside of the quick settings, it's in EMS. And the first screen that you'll see when you click that is the time of use settings, enabling AC charge, charge power ratio percentage, and the battery charge and stop percentages, things of this nature. So the time of use will be setting the various modes to move in and out of for the inverter. Say in a different application, we want to export some energy to the grid at certain times, or we only want to program grid charging of the battery at certain times. We can do so within the time of use setting. Enabling AC charge just allows for the inverter to run and charge the battery at its maximum power, even if it has to do so with the grid. So enabling AC charge will allow the grid to charge the battery. And then you can set the various means of charging power here. You can set stop and start ratios and the battery mode setting, of course. These are the different battery mode settings that are available. Load first means that we are powering the load first before we power the battery or export to the grid. Then it would be battery first would be next, where the battery takes priority and is charged first and foremost. And then grid first, where the grid is taking the first and foremost priority exportation to the grid. Then, of course, there's also solar-only backup, and this is a way for keeping the battery charged and then only utilizing the battery in the case of a grid outage. And this is particularly only useful with the SYN device. That SYN device gives you the backup support that you need. Okay, and the last slide I have for you today is updating the software. So it's very simple. The software can be updated from the inverter either online or it can be updated directly here. There's also means to upgrade the inverter with a USB drive. So we will discuss that maybe in some future lessons, maybe in our user manual and inside of our ecosystem, we'll describe how to various different ways to do so. But the most important one is to download it directly after you commission the inverter. We want to make sure that the firmware is up to date. So version upgrade, device information, version upgrade, and then you'll see the two different versions that are possible. So the current version is what is on the inverter and battery now, and then the target is what will be updated to. The update process takes about 15 to 20 minutes. I recommend giving it all of that time. Do not turn the inverter off while it is charging. I wouldn't mess with any part of the inverter while it is updating its software. Yes, we don't want to mess with the inverter when it's updating. Just upgrade the inverter software and be done. Wait about 20-30 minutes. When you know it's finished, all of the lights will be green. The inverter will be showing in working mode. Good. So why are we choosing the Growatt solution? Well, the Growatt is giving many different platforms to monitor your PV system. We are offering Shine Server and Shine Phone. These are the user applications, so the end user monitoring portals. OSS will be your main monitoring portal. We will discuss a little bit about OSS in the next couple of webinars. And then Shine Tools is going to be the local commissioning and the settings changes for the inverter, as well as firmware updates. When you select a Growatt system with Franken Solar, with Growatt, you are guaranteeing your inverter warranty from one single manufacturer, which allows for the use of only one tech support department, only one place to go for resources, for inverter, battery, backup accessory information, and one monitoring portal for all of these devices. With our product really gives great confidence that the customers will be fully supported through all aspects of their energy storage and production systems. A lot more handshaking, a lot more great installations, and we're really happy to see satisfied customers underneath our brand. So enjoy your customer satisfaction in their brand new system today. How would you get started? You would procure a Growatt inverter from Franken Solar, register from them for an installer OSS account, and then begin your installation processes as needed. Adding the data logger, commissioning, installation to the plant, you can always refer back to us at a Growatt or within our webinar here today. I really appreciate you attending this webinar session. It was a lot of fun. I really do like giving best installation practice trainings. So if you would like to join our next webinar session, it will be hosted here again. It'll be on August 24th at 1 p.m. Eastern Standard Time. And in this presentation, we're going to go over the installation of the SYN device, some of the key components behind a whole home backup system, ways to size off that whole home backup system. And I really hope to see you there.
Awesome, Zach. So thank you, first of all. We're going to get into some questions that people may have.
Sure.
But before that, I just want to quickly remind people that if they're interested in this product, feel free to please reach out to your Franken Solar account rep. If you don't have one, send an email to sales@frankensolar.ca or give us a phone call, and we'd be happy to set you up with an account rep and share our price list and everything else as well. So we'd look forward to hearing from you guys. To the questions, there's one from Leo. He says, let's say I have a 25 kilowatt hour APX pack. Are there options on how to stack and configure the batteries? Like, can you have multiple stacks? How does that sort of thing look like?
Yeah, so there's multiple different ways to stack any size system. The 25 kilowatt hour would be 5 stacks. So the configurations that are possible would be to stack floor to ceiling, 5 of those, and that from there it would be 4 to 1, where you would have your one separate module and a battery cluster. But obviously, whatever is best for you, my recommendation for a 25 kilowatt hour system, if you cannot do floor to ceiling, then to stack it as 3 and 2, and that would give you the most the most bang for your buck.
But obviously, the best way to do it is all on top of each other if possible. it's the neatest looking solution. And you can do up to 6 on top of each other, right?
Yes, that's correct.
I also have a questions on when we talk about arbitrage. Um, so for example, in Ontario, and we have different rules in different provinces here, but we have a ultra low overnight rate of 2.4 cents per kilowatt hour, and then an on-peak rate on which is on weekdays 4 to 9 p.m. at 24 cents per kilowatt hour. Is it easy to configure that in your monitoring platform or in your battery platform to accomplish this?
Yes, yes, yes. It's very easy to accomplish this. We give you the tools needed to create a really nice time of use structure system. Many different ways to configure, up to 9 different ways to configure each of those energy management systems based on weekday, based on weekend, based on the month. But yes, it's very easy to accomplish what you have just said with our system. Um, Programming the inverter to export energy during the nights or only import. There's so many different configurations and possibilities with that. There's many different ways to go.
Awesome. And can you remind me of the, or remind everyone of the warranty on the batteries, on how that works and how it's warranted?
Yes, so the battery is warranted for 10 years. It has a standard 10-year warranty as well as the inverter. The inverter has an option to go to 20 years warranty. I don't believe the battery has this option. It's rated for 6,000 cycles, so I wouldn't imagine we give the option for a 20-year warranty. So for the APX, it is 10 years. And then, so you plan on mixing, we give you the ability to mix and match different battery cells, correct?
Yes.
So we also need to, we have tracking for each of those battery cells to make sure that batteries that have been installed 5 years, and then the next one, another set of batteries gets installed in 5 years. We're tracking those warranties individually. I think that's important to note. We're not tracking the warranty of the entire APX because you're mixing old and new batteries in. Each battery module is warranted on its own terms.
Perfect. And I mean, 6,000 cycles, if you cycle it once a day, I mean, that is, 18 years, I think, or something like that.
Yeah, it's quite a long
So,
time.
so
Yes.
I mean, the arbitrage function in places like Ontario makes a lot of sense, even if it doesn't necessarily have a huge ROI, but it definitely will pay for the battery itself, and you have a backup function. On top of that, for a homeowner, which in recent years we've had a lot of um, outages. For example, I live in Orangeville, about an hour north of Toronto, and we had just before Christmas, I think actually it was Christmas Eve, we had like 12 hours of no electricity. And this is not like a small town. Like, it is a small town, but
Yeah.
there's 30,000 people living in there, right? And like 95% of the town didn't have power. So just because we had a blizzard, right? So this is definitely something that I think there's people like that backup function. And
Yes.
this
I
is
think
kind
that
of
it's going
like
to solve.
combining the two. So
I think that the battery backup function is going to be a really nice feature. I'm excited to really display exactly what is involved with the battery backup and the EMS modes in the next webinar. The SYN device is service entrance rated.
yeah,
There's a lot that goes in with the SYN, so I'm really happy to show you in the next webinar
next week. Yeah,
exactly what you get. Yeah.
absolutely. Okay, cool. If there's no further questions, then we'll end this webinar now. And we'll see. Hopefully, we'll see everyone next week for the SYN 200 presentation. So
Yes,
thank,
definitely.
thank you very much, Zach, and everyone for attending. Have a good day.
Yes, thank you, Danny. Have a good rest of your day.
Yeah, bye.